Alrighty, so we are recording now, our class, and we're going to pick up where we left off. Now, I had mentioned to you that there was a quiz coming up today. You got that announcement, right? And I asked you to prepare for that. Now, here's the thing. It is open notes, okay? And then there are course notes that Dr. Pilling has written that we're going to be giving to you as we go, okay? And in fact, one of the chapters is now visible to you on Canvas. Chapter 2 of the notes are there under the modules. Oh, there you are. Great. Okay. And then Chapter 3 will appear in a few minutes. So these are references that you can use during the quiz. Your notes, you can use this Linux OS cheat sheet, okay, that you probably got last semester, but then I gave to you last time in class. You can use that as well to do the quiz. We will do the quiz today if there is sufficient time, okay? I will tell you that the other two sections did not have time to get to the quiz, so we'll see if we do. If we don't, we'll just do it on Thursday, okay? All right, so let's get going. First thing I want to mention to you is there are going to be tutoring hours available for this class through Student Success Center. They've announced their schedule already. I know there are a couple people tutoring because Dylan, who is helping us today, told me that that was the case. But I wanted to also tell you that one of the learning assistants from the classrooms is also going to be available for tutoring. You may know John. He assisted me with the Tuesday, Thursday, 12:30 section of ENR 200 last semester. So those of you that were in that class, you probably remember him. He's going to be available as follows on Thursdays. And it will be in TAM 218. Okay, the room around the corner, right? Okay, the little room where we have tutoring. And then also he'll be available on Fridays. So you might want to write this down, okay? Just in case you're having trouble with something in this class. He is helpful for other classes too. He's a very helpful guy, okay? So you could ask him about physics, you could ask him about calculus, you know, anything that you're working on, he probably would be able to help you, okay? So I just wanted to let you know about that, okay? Now, we're going to start off with some stuff in this class. Let's open up the LX Terminal window. Okay, so you go to System Tools and LX Terminal, okay, and then I am going to enlarge the font on my screen, Control-Shift+, okay, and then I'm going to shrink the window down a little bit. This is to help you see what I'm doing here, okay? You don't have to do that yourself. You can do it if you like. All right, I'm going to make it just a little bit bigger, because I like to make it bigger. There we go. Okay. All right, now I'm going to start talking to you about some of the things that we see here. The first thing is, and some of this will be review, you may recall this depending on how you did things, PWD tells you where you are. One of the beauties of working with Linux is knowing where you are and where stuff is, where you're keeping things on this computer, how things are structured, okay? So when you log in, when you open up a terminal window, okay, you are automatically placed in what's known as your home directory, okay? Now you see the path is given here. The path where you have different levels separated with these forward slashes, okay? If you're used to Windows, you may recall that you can occasionally see path names there, but they use a backslash. Windows, they do that, it's proprietary, okay, but generally this is the default way to do it with the forward slashes. In fact, when you type in a URL into a browser, you're using forward slashes, okay, because the internet runs on Linux, okay? This is the Linux style of doing things. Now, how does this all work? I'm going to show you the file structure system. I'm going to open up my browser and show this to you. I have a couple of slides here that I want to show you. Let me go into here. Here we go. Okay, so this is the Linux file system, okay? So everything is arranged in a tree structure. You can think of it that way, okay? And then this very top is the root, okay? It is the root of the file system, okay? And that's just the plain old slash. And you can think of this as the entrance to the building, okay, where everything is, right? That's the doorway. You stand there, okay, and then you can think of these lines, they link you to various rooms, okay? So each one of these boxes is a room. So you can go down from the root level, and then you can go along different paths, okay? And you can navigate around the file system. Okay, and as you see, at each level, you add another string to the path name, like a word, okay? And every level is separated with these slashes, all right? So root is where it all starts, right? Okay, up there. But when you log in, as I said, you come into your home directory. Now remember, you logged in as student, okay? Because your username is student, your home directory is home, and then your username, okay? Now, when you get better at working with the computer, you can actually put other accounts on this computer that you have. You could put an account on there with your own personal name, okay? Let's say your name is Joe, okay? Then you can set up an account username Joe, and when Joe logs in as Joe, his home directory is /home/Joe, okay? So that's how things are organized here to keep the file system tidy. So the idea is that each of these levels, or these things, we call them directories, okay? They're in a directory, okay? The terminology that's used in Windows and probably Mac is folders, okay? So you can think of it that way. A directory is just a folder, or you can think of it as a room in the building, all right? And then the files are objects that you leave in the room, okay? So now let's go out of this. Okay, that's all I want to do with this right now. Okay, so like I said, when you do print working directory, the default location is home student, all right? Now, when you want to change directories, you want to go someplace else, you could say, okay, I want to navigate to another location. Well, one thing that's helpful is to know what's in the room that you're in. Here you are, okay? So the prompt is the $, right? That tilde is another shortcut way to describe the home directory. That tilde there, okay, that tells you the level that you're at, okay? It's to remind you where you are. ls is list the contents of this directory, okay? Now, we have a problem here in that everything just kind of rolls off the screen here, right? Because there's just so much stuff in this directory. Now, I could make the window bigger. That would help a little bit, and I do it again. Okay, I could just run the whole thing again. That's possible. That might help a little bit, but it's just this big list of things, right? So something else that I can do is I can do ls, and then I can use a pipe, okay? And I can type more, okay? And when I do that, what ends up happening is it will show me a screen full. Okay, and then you see the more at the bottom, right? Okay, what do I see here? I see a bunch of things that are in green, okay? The things that are in that green color are, I guess, a combination of things. I guess everything is shown in green when I use more, unfortunately, because I wanted to be able to distinguish among the different things I have here, but that's okay. So when I want to go on and show the next screen, then I just hit the space bar, all right? So let me just do ls. Yeah, I'm going to have to go to a different directory, I think. Let's navigate into this. I've made a directory. You guys probably should make a directory. Let's do make directory. Let's make one, okay? A new directory at this level called ENR210, okay? Now you'll notice there's no space, right? In the name of the directory, I cannot put any spaces. You may be accustomed to having spaces in file names and directory names from using Windows. You cannot do that in Linux, okay? You have to leave that out, so I just make it all smushed together as a string. I've made the directory, okay? So if I list what I have here, it will show up, okay? There it is. It's in blue. Okay, you see here it is in blue? Actually, this is showing everything, isn't it? Okay, this is good. I want to show everything here. Anything that's in blue here is a directory. The stuff that's in green is files, okay? And then I have an MP4 file here. This is a audio video file that I made from when I recorded the class last Thursday, okay? So the different file types are distinguished by color. I want to navigate into this ENR210 directory, so I'm going to say change directory. I want to go from the level that I'm at, and I want to go down into ENR210, okay? Now, you may already know about this, but I'm going to remind you, if you hit tab, okay, start to type something and you hit tab, then what will happen is it will complete as far as it can uniquely, okay? So if I type in E, capital E, and I want to change directories, what happens now is in the terminal window, it looks for directories that start with E, okay? And every directory that starts with E also is followed by N, and then by R, and then by a 2. Okay, so it will complete out that far, and then it can't go any farther because it doesn't know which one I want to go down, right? So if I just hit, if I say return, it's not going to do anything, right? So let me get the command back by using the up arrow down in the southeast quadrant of the keyboard. And if I try to complete by using tab again, it won't go any farther, right? Because it doesn't know what I want to do. If I hit tab again, it's going to show me my options. Okay, so there are 4 different ways that I can legitimately complete the string. Okay, complete the path name. I'm now going to type a 1, and then it's going to tab again. Okay, now I happen to already have a directory called enr210-03, but that's not the one I want. I want this new one, enr210. So it's gone as far as I want. So I'm just going to go enter, and then you see it shows enr210. If I say print working directory, it's going to show me where I am. I've navigated into the enr210 directory. Okay, now I've made this directory. What's in there? Let's do ls and say what's in this room? What's in this directory? The answer is nothing, because we just made it, right? There's nothing in there. But we can make some things and put them in. Okay, so let's do that. Let's do this. If I make something now, I can use touch to make a file. Okay, I can say touch junk 1. Okay, let me just call that. Or let's call it junk 1. Okay. Now if I do ls, there's a file in there called junk 1. I just made it. Okay. What's in the file? Well, I can look to see what's in the file by doing the following. I can type cat junk 1. Okay, that will show me what's inside. There's nothing inside because all the touch does is it creates a file. Yes?
I tried to type ls, I typed la, and it did the exact same thing as ls. What does la do?
LA, man, LA. No manual entry for LA.
Alias.
Is it an alias?
Yeah, it might do.
Did it look exactly the same?
It looked exactly the same.
Okay.
It might do
LS-A is the one I know about, but
Yeah,
I'm not familiar with that. See, usually if you want to know what a command's going to do, you can type man and then the name of the command, like man ls will give you the manual entry for
It's an
ls.
alias for ls-a.
Ah, okay.
Yeah.
All right.
So as you can see, -a just displays all files.
Yes, it
even
displays all
hidden
files.
ones.
Yep.
So files with a period in front of their
Yep.
name will
Yep.
be hidden.
That's
by
correct.
default.
Yep.
All shows them.
So, if you want to know, generally speaking, like on this sheet that you have, there are a bunch of commands there, and you can read about what they do. Like there's a brief description of each of these commands on the paper, right? But you can find out more about them by using man, okay? And that will help you to go into the documentation that's available for it, okay? You can use this, and it takes over the window, the terminal window, okay, and shows all the different things that you can do with ls, okay? I'm going to quit out of this now. All right. So we just made a file there. I think it might be helpful if we make a file and put it on the desktop, though. So let's navigate to the desktop now, okay? So I'm going to do cd, and when I do that, without specifying a path name, it just is going to put me back in my home directory, okay? So let's remind what that is, pwd, okay? To navigate to the desktop, we go cd desktop. It's one level below the home directory. Okay, so here we are. Okay, now if I make a file, make a new file. Hang on a second. Okay. I'm going to do touch blah. Okay. So now I have a file called blah. Here it is. You probably see one on your desktop. It's just a little white icon with some lines on it. Okay. And it's empty. It has nothing in it. Right? Just like the one we already made. Now I can change this. Watch this. Touch blah. If I can move it, move blah. If I want to rename it, I use the move command. Blah.pdf. Okay, let's do that. So now what's happened is it's changed so that it looks like it's a PDF. Is it really a PDF? No. It's got that icon now, though, because of the extension that we used, right? So it's a little deceptive. Let's try this again. Move, blah. I'm going to use tab complete. No, PDF, there we go. Okay, I'm going to move it to blah.jpg. Okay, so it did the same thing. It changed the icon, okay? So I can try to work with these, but it's not what we think it is. It's just, it's a little deceptive to try to use it this way, okay? I have a file on there already called blah.txt. I'm going to remove that. rm blah. You don't have to do this. I have this from a previous class. I forgot to remove it. Okay. Now, if I take that blah.jpg and I try to open it, okay, I can double click on it, okay, and the image viewer will try to open it because it sees that it has a JPG extension, but it's going to fail because there's nothing in there. It's an empty file. Okay, so that's not so great. Okay, that's the problem with double clicking on things, because there's an assumption made about what type of file you have based on the extension. Okay, so it's not going to necessarily be accurate. Now, we can actually put some things into that file. Okay, I can do the following. I can, if I cat blah.txt, I actually want to move this JPEG and make it blah.txt. So let's do move blah.jpg. You can use tab complete, and we're going to change the name of it to blah.txt. Okay, so there we have it. If I do cat on that file, it's empty, right? We know that already because all we did was create it. All right, so what we want to do now is put some text into the file. So here's how we do it. Echo, and then use double quotes, I am not a JPEG. Okay? And where are we going to direct this? Well, let's just type it first. Okay, so you know what happens when you do echo, it's just going to print to the screen, right? Because that's the default output goes to the screen. Okay? But we want to redirect this now. Okay, so let's get the command back. Echo, I am not a JPEG, and let's just send it into eSpeak to make sure that it's.
I am not a JPG.
Okay, so hopefully yours is going to do that too. Make sure your eSpeak work. There you go. Okay, great. Okay, now let's take that. Let's get it back again, and instead of eSpeak, we're now going to send it. Okay, this is a redirective output rather than a pipe. Redirective output into, very good, into blah.txt. Okay, that arrow should mean that the text will go into blah.txt. Okay, so now when we cat blah.txt, you should see that. Okay, that text now appears in there. Okay. Now, in order for us to add to that file, okay, we need to, let's say I want to put the hello world. I am a text file, like that, okay? We want to put it into blah.txt, okay? So let's go ahead and do this, blah.txt, okay? Okay, so that should work. Let's now cat the file. Okay, and it says, hello world, I am a text file. So what happened to I am not a JPG? Yes?
Two arrows into it?
Yeah, it overwrites. Okay, so if you have just the one arrow, you're going to overwrite whatever's there. Okay, if you want to actually append to what's there, let's go back to the I am not a JPG. Okay, and I'll go back to that. I'm going to edit it now. Put two arrows. The double arrow will append to whatever is in there. Okay, so we do that, and then we cat the file, and now we have two lines. Okay, so this is a way that we can put things in files. We can put text in. This is just text. Okay, it is raw text. It is ASCII. Okay, I was going to tell you a little bit about ASCII. I wrote down what ASCII stands for someplace. Oh yeah, okay, so ASCII. All right, this is American Standard Code for Information Exchange. Okay, and that is the kind of file that we're going to be working with, okay? Every character uses 7 bits, okay, to display. This is the basic ASCII symbol set, and so internally they're represented as 0. Each symbol has a number associated with it, 0 through 127. There's a table in the notes. You'll see it on Canvas. It's table 3.1. Okay, and that will list out the basic ASCII set. I will tell you, when I was reading through the notes, it was alluded to early in chapter 3, and then I thought, where is this table? It's not on this page. Where is it? Where is it? It's actually on the last page of the chapter. Yes, Dylan?
Just a minor thing. I think it's interchange.
Oh yeah, interchange, thank you. It is, because that start with I, right? Thank you. Interchange. Yeah, I had written that down too. I just wrote it down on the board. Sorry. Interchange. Okay, so we're dealing with plain text. This is a plain text file. Okay, so plain text means you can get what's in there by just typing cat. You can type more. You can access it using an editor like Featherpad. Okay, there are other editors that we're going to be learning about. We're going to be learning about Vim. Is anybody here familiar with Vim? You're familiar with Vim? Okay, I know you're familiar with Vim. Okay, yeah, so so we'll be learning Vim later on. Okay, but we'll be using Featherpad initially, and I know that some of you worked with me on Featherpad before, so you probably have used that. And this will be working with these plain text files that we're building here, okay? When we want to use files, because the thing is, we're going to be using the command line quite a bit, but we're limited as to what we can do there. You can put in command after command after command, but if you can put everything in a file, then you can start a set of instructions. You can have the computer do stuff. You start it off by saying, just do everything that's listed in this file, and then you can walk away, and it can run while you're not there, okay, which is very nice to be able to do. You can do a lot more complicated things that way, okay? All right. Okay, now, let's go back now to the home directory, okay? And let's look now at what we have here. When we look at stuff here, we see that we can do ls and list out what's here. Okay, I don't know why it's showing it like this. You probably don't have quite as much stuff in your directory as I do. Let me see if I can make that. No, why is
I
it?
think it's mainly just zoomed in.
It's because it's zoomed in? Yeah, that's probably why.
So
Okay.
some of your text boxes are-
Yeah, I should probably shrink this down a little bit. Yeah, there we go. Okay. Let me just do ls now. Yeah, that's better. Okay. All right. So this is just the basic listing of what we have, but there are other ways that we can show stuff. Like, for example, as Dylan alluded to, you can type ls-a, okay? And that's going to show you all the files that are there, all right? And so there are some additional files that have dots in front of them that are ordinarily hidden from you because they're not your personal files, right? They're files that make other stuff happen while you're doing things. So ordinarily you're not going to want to look at that unless you absolutely do want to see every single thing that's in there. Okay. Now I'm going to type clear, which is going to clear my screen. That's something that you might want to know about also, clear. It's pretty useful. Okay. What we want to do now is do ls-l. Okay. So when we do ls-l, this is going to show what's known as the long form of the listings in the directory. Okay. And you see that it shows you a whole bunch of additional stuff, okay? Like you can kind of probably guess what some of it is. So I'm going to just talk about what each of these columns means, and I'm going to start at the right, okay? On the right side, you see the name of the file, okay? So over here, that's pretty understandable that you're used to seeing those. Some of them are files, some of them are directories. Like there's an Arduino directory, there's a desktop directory, right? And these other directories that are here in blue. The MP4 file, which is in this kind of magenta color, right, pink. And then you've got some other files that are regular files, okay, that are green. Now, immediately to the left of that, you have when the file was created or last modified, okay? And that's just the timestamp for it. Then to the left of that is the size of the file, okay? So some of them are pretty big. Like this MP4 file I have here is huge. I'm probably going to need to delete this pretty soon because it's taking up space, right? And then beyond that, what we have here is information about who made the file, okay, the owner of the file. That's the left of these two columns. Everything says student here, right? And then the group of people that have access to the file. Okay, now right now, this idea of having a group where you restrict access to a certain group is not really a thing because we only have one user on your computer. But remember that this is basically a server, what you have here, and so you could have multiple users on here, and you could decide that you were going to allow, you know, certain files to be visible to some people or accessible to some people and not to others, all right? Now, the stuff that's beyond that, okay, this is, I think it's the number of links, right? The thing that's to the left of it, that number that's there, okay, the things that are linked to it.
I think so.
I think
it might be what the number of files contained in it. 'Cause
Yeah.
Because the ones with numbers have D at the.
Yes, that's correct. Yes, right. So the ones that are just ones are just regular files, right? Yeah, I think you're right. So, for example, if we go down into Arduino, right, we see a 10 there. Let's do CD Arduino. Okay, and we do LS. There's more, but there's probably stuff underneath it because these are all directories, right?
Yeah,
So.
if you did a LS dash there, you'd probably get numbers that added up.
No, it's more than 10, isn't it? Okay, so that's still a little bit of a mystery then.
It
But
might be including the base directory.
okay, yeah, all right. So we'll just assume that, but it's basically tells you how many. Whoops, CD dot dot. CD dot dot takes you up one level. Okay, so we want to go back up here, and let's do ls-l again. Okay. Now the stuff that's on the far left, it explains what kind of file you're looking at. Okay, the one you see that's in the very first column, some of them are marked D. That just means that those are directories, okay, which you can tell from the colors, right? Anything that's blue is a directory, but it's also marked D in the far left. And then the other ones that are files have dashes instead, okay? Then after that, there are 9 slots, okay? So this slot here, RWX right here. Okay, I'm just using that as the first example. That shows the permissions for the Arduino directory, that first entry, for the owner. And the owner is you, student, right? This is the owner name, okay? This is what you can do with the directory, okay? You're allowed to read, to write, and to execute the contents of the directory. Okay, if there are executable files in there. People in your group. Okay, right now the only group that exists on your computer is student. It's the same as you, the owner. Okay, that just happens to be true. This is permissions for your group. Read, write, and execute. Okay? Then after that, you have permissions for all users. Okay? Others, okay? There's nobody else right now, but there could be others. The default is they can read and they can execute, but they cannot write, meaning anybody else that would be using this computer can not change what's inside. They can't write anything, okay? So that's how that goes. And so you see that there are these various permissions associated with all these different things, okay? Now, can these be changed? Yes, they can. But we aren't necessarily going to want to do that right now, okay? I don't want to get too much into how to change things because I don't want you to mistakenly delete something, like something very important on here, right? There's a lot of power associated with this, but I am showing you that this is the long form directory and that there are ways that you can modify what you have here, okay, the different permissions. So let's go now into this ENR 210 directory, okay, CD ENR 210, okay, and there you have that file junk1, okay, so let's look at that and let's do ls-l. Okay, so right now, okay, this is not It's just a text file, okay? It's not set up to be executed, okay? You could change it, but it's not, it doesn't have anything in it that could be executed. There's no executable code in there, all right? So there's no point in doing that. Now, we can change the permissions here, okay? Let's say that we would like, right now it's set up so it's just a regular file. That first slot has a dash, okay? Read and write permissions for you, the owner. Read and write permission for the group, and read permission only for others, okay? So let's make it now so that we can, so that the others can write. Okay, this is how we do it. chmod, so this is to change the mode, okay? For others, we want to add that they can write. Okay, so that's the syntax. chmod, O means others, plus we're adding the write capability. And then the name of the file is junk1. Okay? Now when I do ls-l, I see I've changed that to a W. Okay? Now this, as I said, it's not an executable file, but let's just say we want to change it and make it so that it is an executable file. Okay? Right? chmod. Let's say we want to do it for the user. That's me. I'm the user. Okay? The owner, right, of the file. I want to add that I can execute this like that. Okay? Junk1. Right? So then I do ls-l again, and I've added that capability, although it isn't truly an executable file, but I could, in theory, do that. Okay? If I want to change it for everybody, make it so that everybody can execute this, I can do all plus x junk1. Okay, now I do ls-l, and there we have it. Everybody can execute now. All right, now let's say I want to take it away. chmod a for everybody. I don't want it to be executable. Junk1. Okay, and then I say ls-l. Okay, so that's changing permissions. Yes?
What's the letter if we want to change just for the middle user?
The middle one? That's a good question. It is G. Okay, so let's add executable for G. Chmod, okay, G plus X, junk1. Okay? Okay, it's added in. Okay, so the letter for you as the owner, okay, the user is U. The letter for the group is G. The letter for others is O, and the letter for everybody is all A. Okay, those are the letters. All right. All right.
Just a quick note in this command also.
Yeah.
Just as you can use plus to add these, you can use minus if you want to revert it.
Yep. If minus, we did an example with a minus, but yes, if you want to take away one of these things, it's the minus sign. If you want to add it, it's the plus sign.
I think you can also use numbers.
You can, but we're not going to address that right now. It's octal, so we're going to wait. We're going to hold off on that. Yes, but it is encoded with numbers ordinarily. Okay. All right. So let's now talk about directories again. All right, so here we are, right? And we have just that one file in there. Okay, let's say we're going to make a new directory under here. Okay, let me do clear so I get my screen cleared. Okay, so we're going to make directory. We'll call it D1, directory 1. Okay, and then we'll go down into directory 1, cd D1. Okay, and then let's make some files here. File 1, okay, touch file 2, touch file 3. Okay, and then we go ls and we see we have these 3 files. They're all empty, but they're files, okay? And then let's go up a level and say, you know, I regret making that directory. It's kind of a useless directory, right? I've got that D1 directory. Let's just delete it. Okay, so in order to delete a directory, you do rmdir, okay? Remove directory, right? And then I type D1. Okay, now I get warned, nope, you can't do it. You can't do it. You're not supposed to do this because there's stuff in that directory. You can't delete it, right? So there's two ways we can deal with this. One would be to go back into the directory. All right, let's go down into the directory, D1, right? And say, I want to remove everything, okay? All right, we can do RM and we could remove it one file at a time, which would be a little tedious, although there's only 3 of them. We could do that, RM, right? We could use, we haven't done this yet, started that we could use wildcards, okay? Wildcard is where you put in a symbol that says anything, means anything. We could do that, all right? So I could do that now. I could say, well, every single one here starts with the word file, right? But they all end in different things, so I can put in an asterisk, okay? And that means anything or nothing can follow the string FILE, okay? And then when I do that, it will remove everything. It's very powerful but a little risky. Okay, that's one thing you got to keep in mind when you're doing stuff here, is you have a lot of control over what goes on here. It's not like maybe Windows computer that you're accustomed to where there's a trash can or you can undo stuff, right? You know, you have to be careful about what you do. So I've now removed this file, right? All the files are gone, so now I could go back up and remove the directory. Let's put in a new file though, okay, because I want to show you what happens. There's another way we can do this. Let's make another file. Let's put in file 4. Okay, so now we have file 4 here, right? Let's go back up. Okay, I still want to remove the directory, but I don't want to have to go back in and remove all of the files that are in there. So what I can do is the following. I can say remove directory -r. It's a recursive remove. It's going to remove not just the directory, but all the contents of the directory, okay? Again, this is powerful, but a little bit risky. Be careful, all right? You don't want to inadvertently remove something because it's going to be gone, right? So then I put D1. So this will remove the directory and its contents. Whoops, did I do it wrong? Oh, what's wrong with this?
I think for what you're trying to do, you wouldn't use remove directly. Just use
Remove?
dash recursive, because then it would go into the file. The directory.
Oh. Well, I don't want to do that. I don't want to remove everything, right? If I do rm dash,
Well, if you did
dash
RM,
r,
Yeah, RM-R D1.
D1. Oh, okay, D1. Sorry. There we go. All right, that worked. Thank you. Okay, it's gone. There was RM. I thought it would be RM dir. Thank you. Okay, that was news to me. I just learned something. Okay. All right, so that's gone now. All right, so that's remove directory. We know how to make a directory. mkdir, remove directory, rmdir, remove. Okay, you can remove a file. You can recursively remove stuff inside a directory and the directory itself. Okay, we know if you want to move, if you want to change the name of a file, we have chunk1. Let's call it file A. Okay, file capital A. Okay, so case sensitivity, everything in Linux is case sensitive. Capital A is different from lowercase a, all right? Means something different. So we now have renamed this file, right? Okay, we can make a copy of it, file A. I'm going to use tab complete. I want to call this file B. Okay, so now we have the two files, file A and file B, all right? I can move this file. Let's say I want to move file B to my home directory. I can do it in a couple of different ways. I can do mv file B, okay, and I can do it like this. I can use tilde because that means home directory. It's a shortcut way of doing it. And then I can put in the slash. I don't want to change the name of the file, so I'm just going to put a dot. Okay, that means take the name of the file and paste it in there. Okay, so I've just moved it. If I do ls, I see that it's no longer in this directory. Okay, I can list what's in my home directory without going to my home directory by just doing ls tilde. There it is, file B. Okay. Okay, right there. All right. So I've got that done. Couple more things that we want to look at here. Do you guys, you can see what's installed on your computer. Okay, I'm just going to shift gears now. Using which, okay, like for example, you can look here and you should see LaTeX, right? We use LaTeX in ENR 200, so user bin LaTeX, so that shows that the LaTeX executable is installed there, all right, in that, and it's in that directory, you know where it is. How about which tree? Do you guys have that? I have it installed. Do you have tree installed? Yeah? Okay, it's already there? Okay. Does everybody have that? Is there anybody that does not have tree? No, you all got it? Okay. So you can use tree to show you a tree structure of your directories, tree-d, like I'm in this ENR 210 directory right now. Oh, there aren't any directories. I better go home. Okay, cd, I'll just go to my home directory, okay, tree-d, okay, and then you can see the structure of your directories that way. It's kind of a nice way to visualize things, okay. That's another way you can see how things are laid out there, okay. All right, a few more things that are useful to know about. Okay, one of them is what are the processes that are running? PS will show you the processes that are running right now. Okay, so right now we have this terminal window open. Okay, that's bash. It's called bash. Okay, it's a shell. Okay, and also we have the process itself that I just called PS. Those are the only things that are running right now. You could have other things running, right? Like for example, if I go down into my ENR 200 directory, hopefully you still have yours, okay, and I say I would like to see all of the PDF files in this directory, I can say list out everything that starts with, it could be any starting, but it ends with .pdf, okay, and then show me everything that I have here. I've got a bunch of files left over from last semester, okay. I can do xpdf, and then I use an ampersand to launch the process, and a new window opens up, okay, and I can still type to my original window over here, okay. I get the prompt back so I can type stuff here. Now when I put the mouse over my xpdf window, I can type in the letter O, okay, and then it's going to give me some options of things that I can open up, and so it gives me a list of PDFs that I have available here. Let's say I open up, I don't know which one. Let's do color boxes. Okay, open. Okay, so this was some stuff we did with color boxes last semester. All right, now I've got this process running. Let me see if it shows up over here. If I go back over here and I say show me the processes that are running, okay? So bash is running, it's this window that's open, right? I've got xpdf running, and I have this show me the processes process running, okay? And they're not really, not much is going on right now, okay? But I'm just showing you this is a way to see what is running in the background or anything that you're doing on the computer at that time. I would like to know how much free space I have on my computer, so I type df for that. Okay, whoops, it's showing me a whole bunch of stuff. I think I'm going to close down this PDF window now. Okay, I don't need that anymore. Let me open this up so it's a little bit bigger. Okay, so you can see the file system and then how much you're using. There's quite a bit of space on this computer. It's got quite a lot of room. You can put stuff on here. Okay, but that's a way to show how much free disk space there is. Okay. Here's another thing that's kind of useful. You might want to figure out where you left something in a file. Okay, so here I am. I'm in one of my ENR 200 directories. Okay, I'm going to say clear now. I say, you know, I was working with these files. I don't quite remember what file I had that certain thing in. I'd like to know without having to open every single file and scroll all the way through it and look at it and where is the thing I'm interested in. Okay, maybe I'd like to find, say, color box. Okay, I say, well, I know it was a text file. Okay, so let me just list out the text files that I have in here. Okay, I've got a bunch of those. Okay, there's one called colorboxes.tex. It's probably in there, right? I can use a command that's called grep. Grep is an extremely useful command. Okay? Grep helps you to find things in files without opening the files. So grep, G-E-R-P, stands for global regular expression print. Okay? And regular expressions are super important in what we're going to be doing this semester, but this is just starting off and giving you a taste of how it works. Okay, so let's say I want to find a particular string. Okay, like a set of characters. Let's say it's color box. All right, let's say I want to find color box. Okay, and I'm going to look in this file called colorboxes.tex. Okay, sure enough, it's in there. Okay, so what happens when I use grep is every line in the file that contains that sequence of characters, color box, will be printed to the screen. Okay, and it just puts it in there, and it helpfully highlights it so you see where it is. Okay, so that's kind of a cool thing and very nice to be able to do. Now, if I wanted to, I could gather all of these up, right, and I could pipe them and put them in a file, right? I could just say, all right, instead of printing to the screen, put this in color box list, okay, or color box list .txt, because it's just a text file, it's not a text file, okay? And then instead of printing to the screen, there it is. And then I do cat color box list, there it is, okay? Printed them out, right? So that's a way to find things, okay? Let me see, is there anything else?
How powerful is grep? Is it able to like just look through a directory or into files and so forth, or do you have to specify specific files?
You can do, let's see, colorbox star.tex. It finds it in every single file in the directory and tells you which file it's in, which is kind of nice also. Okay, so you can use it there, but regular expressions are even more powerful than that. That's just an easy one to use on the command line. Okay. But we'll be doing more with this, don't worry. Okay, so, but yes, you can look through an entire directory to find things, definitely. Okay. All right. Let me see what else we want to do here. Okay, I think I have told you about most of the things that are going to be on the quiz, but I do think I'm going to put off the quiz until next time. What I would like to do now is start talking about writing little programs in the on the command line, okay, and the syntax that we would use to do that, okay. So the stuff I'm going to talk to you about can be found in chapter 3 of the notes, and you have access to chapters 2 and 3. All right, so how is stuff going to work? I'm going to type clear now, all right, and then I'm going to go to this ENR2 210 directory that we have set up. So I have to go up a level and then down into ENR 210. Okay, so I was in that ENR 200 directory. I'm going up to my home directory and then down again to this ENR 210 directory. Okay, so here we are in here. I'm going to remove file A. Okay, and then we're going to get started. Okay, so the first example, we want to talk about how this works. All right, echo. Now I'm going to be running through some examples that are actually in the notes directly. I'm going to be typing them. You should be typing them. But don't worry too much about the fact that you're not writing this down, okay? You have access to previous commands. You can get them back, okay? I'll show you how you can get them back. But I will be posting the video that goes along with the class, and also you will have these examples in text form on Canvas that you'll have access to. Okay, so when we're using echo, right, and we want to type stuff, you notice what we did before. We did this kind of thing. We said hello world, right? This allows us to include spaces, right? Because we enclose it in double quotes. So we'd like to be able to do that. Now, sometimes you might have a string where you want to actually include double quotes. So there's a way you can do that. I'm going to show you what that is now. You can do this. Echo, you can use a single quote. Now, the single quote that we're going to be using is what I would call the right quote, okay? It's a little tricky to show because lots of times, like especially if you're using a computer that has Windows, there's no real distinction made between a left quote and a right quote. But we do that on this computer in Linux, okay? The left quote is found on the key just below the escape key in the northwest corner of your keyboard, okay? And it looks like this, right? Okay? The right quote is found in the just to the left of the enter key, okay? And it looks like this, okay? So the quote that I just typed on my screen is the right quote. Okay, that's the one you want to type for this, okay? That's the one you want to use. And when you look at the book, you're going to see in the notes that this right quote looks like this on the page, and the left quote looks like this on the page, okay? All right, just so you know. But the right quote is the one that I just typed, okay? And that's the one for this is example 3.1 that I'm just showing you now, okay? So let's say we want to type a string that includes double quotes, right? Right now we're using the double quotes to delimit the string that we want to type to the screen, but now we want to include that. So here's how we do it. Single quotes, protect, double quotes. Okay, and then I close it off with another right quote. So I opened with a right quote and I closed with a right quote, which is a little counterintuitive, but that's how this works, okay? There you go. And that allows you to put double quotes in to the string that you're working with, okay? There's another way that you can do this, okay? Echo, I'm going to use double quotes here, okay? You can, the term is called escape. Escape. Now, I'd like to put double quotes around this word, special, meanings. But I'm going to have a problem, right? You see the problem? Okay? I have double quotes all throughout. I'm not making a distinction between them. I want the word special to be enclosed in double quotes, and yet I'm using double quotes to start and end this whole thing. So the way that I handle it is I'm going to use my arrow key, my left arrow key, to go back here. Okay, I'm going to put a slash before the double quote. I put slashes before the double quotes that I want to have actually print. Okay, that's called escaping the character. Meaning, yeah, do you want to say something about this?
This particular code is the one above your interface.
Is above my what?
Is the one above the interface. It's not the same one we use for lines.
Slash. Backward slash.
Like you're using the right one. I'm just clarifying that for people typing.
Okay, I'm sorry, I didn't understand what you were saying. So,
The quote you're using isn't the same slash we use for files.
no.
This is backward slash, not the forward slash.
I'm just clarifying that.
Oh, I see. Okay, yes, thank you for saying that. Yes, so this is the backward slash is used to escape things. The forward slash is used for files. Yes, that's correct. Okay, thank you. So the backward slash appears above the enter key. The forward slash that we use in file names and directories is just next to the shift key. Okay, thank you. All right, so that, pardon me, that allows you to, that's another way that you can put in the quotes, okay? Because the double quote has its job to do, right? But if you don't want it to do its job, if you want it to just print to the screen, this is a way you can do it with the slashes in front of it. Pardon me. Okay, all right, another one. Okay, so sometimes you want to actually you can actually put executable pieces of code into the echo. Okay, this is how we do it. Echo. Okay, now we're going to use double quotes to enclose the whole thing. All right. There's. Okay, and then I would like to put in. Let's let's see. Yes, I'll do this example because this is something that's a little strange, but we'll go ahead and do it. Okay. Now this is using the left quote, okay? The left quote. So, which on my screen looks different, okay? It's got that slanty thing on it. Using the left quote, okay? LSWC-L, okay? And then we use another left quote, okay? Files in, left quote again, PWD. Close, okay? And then double quotes. Okay, so what are we doing here? So we're using the double quotes, the single quote that's a left quote to enclose this and also this, okay? Right? We're using the double quotes to make the whole string. Now there's one other thing we have to deal with, and that's that single quote there in the word theirs, okay? We have to put escape in for that one. So let's use the arrow key to go back to deal with that. If I want to put an apostrophe in a case like this, you have to put that in. Okay. So all three kinds of quotes are used here. Okay. The right quote is used as an apostrophe. The left quotes are used to enclose these little pieces of code, and the whole string is enclosed in the double quotes. Okay. So go ahead. Now, what do you see there? Okay, what happened? The ls/WC with the pipe, okay? List and then show me more, okay? That counts up the number of files, okay? And then PWD shows prints working directory, okay? So that actually carried out that command, okay? That's what happened in each of these cases. The command was carried out. So using the little left quotes allows you to include a little piece of code that will execute and be pasted into what you echo back. Okay? Does everybody follow that? See, it's a little bit complicated. Okay? All right. Let's do one that's similar. Okay? This one's a little clearer, I think. Okay? We're going to type basically the same thing, but with a slightly different syntax. Okay? So we start off with theirs. Okay, we're going to do the same thing here. Put it.
You need to escape the right quote.
Don't think you need to escape.
Like if you look up your output before, like finish the slash.
With their /s.
That one that I don't need to do that?
No.
The notes include it though, so that's why I put it in.
Oh.
Okay, so did you try
tried
it?
without the slash and it still works.
It still worked?
Yeah.
Okay, that's good to know. Thank you. So I'll just try it then without the
I
slash.
think that might have just been an example that was not the same symbol.
Okay.
So like you don't need to escape it.
Yeah, I was wondering about that because I thought, why am I escaping it? I shouldn't need to, but okay. But it still works if you escape it, so let's not escape it because it's easier if we don't have to, right? So, okay, so let's just put in theirs, okay? I'll tell Dr. Pilling about that. Okay, so this one, you can put $, parenthesis, LS, okay, /WC-L. So it's the same command as before, okay? Except now there's a $sign instead of those quotes, right? And I'm going to put a space in here because, yeah, file, let's see, files, in, and then instead of enclosing this in those left quotes, I put a $sign and then I put PWD. Okay. Honestly, I think this is a little clearer. You use a $sign and then these parentheses to say, this is something I want to execute. And then paste into the thing I echo back. Okay? So let's do that. Okay? So you should have something like that here. Hopefully you do. Okay. Now let's say that I really want, instead of getting this to execute and give me values, like 0 and then the path name of where I am, okay? Let's say I really want to just print that exact text to the screen, okay? Then I'm going to have to do something slightly different, okay? Let's try this first, okay? I'm going to type the echo Okay, and then I'm going to put open quote, and it's the right hand quote. So that's the one on the right side of the keyboard. Okay, C. Okay. Now I'm going to put a semicolon. Echo. It worked. Let's try this, okay? So what happened here? 2 commands in a row on one line, right? Separated by a semicolon. This is a way that you can do multiple things all in the command line. Okay, you don't have to just execute one command at a time. You can put several together with the semicolons as delimiters, all right? Now let's go back and get that again. Okay, use the up arrow key to get back my command, all right? Now, instead of it worked, we're going to put something else in there, okay? I'm going to say echo, all right? And then, whoops, you know what? I'm going to get my notes out because I have to get the right thing here. Okay, now I do have to use the backslash. Well, I'll just put in a print. Go like that. Echo, there's. And now I'm going to type the $, LC, WC, dash L. Okay, in, $, PWD. Okay, so it's similar, but now we have single quotes instead. I gotta go back here and fix this up a little bit though. Okay, I need another space here. Okay, so we have this now. It's very similar to 2 lines above, except it's enclosed in single quotes. Now, the single quote that we're using is the right quote. The other thing is, though, there are 3 single quotes in here, right? 2 to enclose the whole thing, and then 1 is functioning as an apostrophe. And to make sure it functions properly as an apostrophe, we do have to put the backslash in, okay, to escape it. Oops, it didn't work. Ah, why didn't it work? I must have screwed up somehow. Sorry, let me figure this out now. Oh yeah, okay. Hang on a second.
Does the apostrophe for the theirs?
Yes, that's the problem. So what do we have to do here? Okay, what we have to do is we have to leave. Let me go back and get this again. We have to leave the wait, let me get rid of this X. Why is there an X there? I don't want an X. Okay, let me go back. We have to leave the environment here. Boom, like that. Okay, so the word there is in single quotes. Okay. And then we escape the apostrophe, and then we open up another string. So there's 2 strings here. There's this string, the word there, which is enclosed in those single quotes. Okay, and then the second string is here. It starts with the S, and it goes all the way to the end. Okay, that should work. Yeah. Okay. So the point of all this is that I'm trying to show you is there are times when you want to put commands in and have them execute, okay, which is what happened earlier where we say there's 0 files in this particular directory. And then there are times where you want to actually make the commands print, okay? So this last one is a way to make the commands print. So this is a little bit complicated. So this example is in the notes. This is example 3.6. We've done 3.1 to 3.6. You're probably going to want to look these over again, okay? All right. Now, we can do some other stuff. Let's say we want to set up a variable. Let's let x equal 99. Now, notice how I type that. You have to type it so that there are no spaces, okay? X equals 99. Then let's type echo, double quotes, the value of x. Now I want to put in x as a variable, so I put a slash in. X is $x. Let's see what happens when we type that. So see what happened when you put the escape in, the slash, in front of this x, first one, the dollar sign, it ignores the fact that it's $x. It's not going to do anything with it, it's just going to print it. Okay? What that says is, ordinarily a dollar sign in here is a special character that has a job to do, okay? But in this case, we're saying, don't ignore the job. I put a slash here, just print it. So that's what it does here. It puts a $x, okay? The second case where I have the $x, I don't have a slash in, and what I'm saying is, tell me what that means. What does that x mean? The x has a value of 99, which we just set, okay? So let's now, I think x is still 99, right? So let's let y equal 1. Okay? And then let's do the next thing. Answer. Notice how I'm typing this. No spaces, okay? This is important. Don't put any spaces in, okay? Put a dollar sign in. Open, open. $x. Put a space in, plus $y. Close, close. Okay? Semicolon. So I'm now setting this new variable called ands. I want it to equal the sum of x and y. Okay? I put a semicolon in. So that closes out the command. I want to put another command in. My next command is echo, double quote, slash, $x plus slash $y is $ands. I've established that ands is a variable name. I've defined what it means. It's the sum of x and y, right? Okay, so again, I put the backslash in front of, in the echo, I put it in front of the x and the y, okay, the $x, the $y, so that I'm not going to go and retrieve the values of x and y. I just want to print them as symbols, okay? And then, but I do want to print the value of ands, okay? Which is 100, right? Because it does the math, because I defined it to be x plus y. And so it executes those two commands in a row. Now, if instead I were to go back and take that same command and I put spaces in like this, space here and a space here, okay? Same thing, except I put those spaces in. Doesn't work. It says command ands not found. Thinks it's a command, okay? So it's very important to maintain the spacing that we had before, okay? You can set up a variable name at the command line, but it cannot have any spaces in it. Okay, do you guys have any questions? We've covered a whole bunch of things. Yes?
I copied the command down like character for character and it's not working for me
Okay.
for some reason.
So which command is it that's not working? This one that I have on the screen right now?
Yes.
Okay. That one? Okay, so that means there is an error, but you just haven't seen it. That's all. Yeah, thanks, Dylan. If you might take a look. Sometimes it helps to have just somebody else look at it, you know? Is everybody able to do this? Are you having trouble? Yeah. Yeah.
What does the dollar sign actually signify?
The dollar sign says this is a variable, okay? So we set it up so that we let x equal 99, right? You remember we typed that x equals 99 in? And then any time later on that I want to refer to it, its actual value, I refer to it using $x. That's a good question. Yeah. I guess I was kind of thinking, I didn't explain that explicitly, but I should have. Yeah. Yeah.
Can you use the characters to store other characters or only integers?
That's a good question. I think you can put in strings. You can put in other things. It doesn't have to be numerical. Numbers are just the easiest thing to start with. Yeah. Any other questions? Okay, that is all we're gonna do today. We will have the quiz next time, okay? So, what I'm gonna suggest that you do to prepare is read through chapter 2. The other thing I'm gonna ask you to do, this is something that we're asking all the classes to do. There is an exercise that I would like you to do for next time. It's exercise 220. In the notes, it's on page 38. So it's exercise 220 on page 38 in the notes. Okay, read chapter 2 notes. You can try the exercises if you wish. You're not required to do them. I'm only asking you to do that one. Okay. In chapter 3, you should read up to page, I would say up to page 50, okay? And if you do that, up to page 50, chapter 3, then you will be well prepared for next time. It's going to review the pages 49 and 50. We'll go over the examples that we just did in class. So you're probably going to want to look at those as well, all right? So I'll see you guys next time.